Today's lesson is on 10.2, which is muscles, health, and homeostasis. So a couple of videos here that I had already posted for students to watch on the muscular system, how it works, and why the muscles get tired. All right, so we're going to talk about muscles, health, and homeostasis. So firstly here is muscle injury. So we can see two comparisons here. We have a strained muscle tissue here and then normal muscle tissue here. So muscle size can decrease or atrophy over time if they are not used, maybe because of injury or illness, or there could be other complications. So when those same fibers are stimulated repetitively, such as weight training or cardiovascular activity, the muscle will increase in size. Common muscle injuries include sprains, strains, cramps, and tendinitis. Most common muscle complication that people experience is the muscle strain. This is when there's stretching or tearing of muscle fibers. A muscle can strain because of sports or exercise, a sudden movement, trying to lift something that's too heavy. And symptoms include there's pain, tightness, swelling, tenderness, and sometimes an inability to move that muscle very well. Important note is that injuries related to athletics are not the only potential problems for the muscular system. There are lots of muscular disorders as well. They're known as myopathies, and they may occur totally unrelated to athletics. And these muscle disorders, they can cause weakness, they can cause pain, or even paralysis. And sometimes there's no known cause for a muscle disorder, and some known causes do include genetics, inflammation, or disease. All right, so here in these two diagrams showing a healthy muscle, the healthy rectus femoris and quadriceps femoris muscles, and here the atrophied. You can see they're much smaller, atrophied rectus femoris and the quadriceps femoris muscles. So muscle atrophy, this is when you start losing muscle, muscle size decreases. It's a concern for people on Earth, but it is also a concern for astronauts who travel to space because of microgravity. So during the early 1970s, experiments with the astronauts on board the NASA Skylab missions led to modifications in diet and exercise programs that were able to compensate for that atrophy because of that microgravity in space. And research still continues in this area. All right, so when we talk about atrophy, that is a reduction in the size, tone, and power of a muscle, and hypertrophy is the exercise-induced increase in muscle mass. So let's pause here and watch this quick video. So this chart is going through some of the common disorders and ailments of the skeletal muscles. So muscular dystrophy, it's a term for several hereditary conditions where the skeletal muscles start to degenerate, they lose their strength, and they gradually get replaced by fatty and fibrous tissue that impedes blood circulation. It accelerates muscle degeneration in a fatal spiral of positive feedback. Botulism, it's muscular paralysis. It's caused by a toxin that's produced by the bacterium Clostridium botulinum, and it prevents the release of the muscle-stimulating compound acetylcholine released by muscle-related cells of the nervous system, and then that leads to paralysis. Cramps are muscle spasms triggered by, for example, strenuous exercise, extreme cold, dehydration, electrolyte imbalance, low blood glucose, or reduced blood flow. Contracture, abnormal muscle shortening. It's not caused by nerve stimulation. It results from the inability to remove those calcium ions from the sarcoplasm or from the contraction of scar tissue, such as severe burns. Fibromyalgia, it's chronic muscular pain and tenderness. It's associated with fatigue, sleep disturbances, and it can be caused by infectious diseases, physical or emotional trauma, or even medications. Crush syndrome, it's a shock-like state following massive crushing of the muscles. For example, after an earthquake, a traffic accident, so on. It's associated with high fever, heart irregularities because of the potassium ions released from the muscles, kidney failure caused by blockage of the renal tubules, with myoglobin released by the traumatized muscles. There's delayed onset muscle soreness. It's usually after strenuous exercise, the pain and stiffness and tenderness. It can be associated with trauma to the muscles, disruptions in the myofibrils and sarcolemma, increased levels of myoglobin and muscle fiber enzymes in the blood. And myositis, that's inflammation. Anytime you see that itis, it is inflammation. So this is muscle inflammation and it's weakness resulting from an infection or an autoimmune disease. Okay, cardiorespiratory fitness. So exercise is an important factor in maintaining health. Exercise helps you maintain a normal blood pressure, a normal heart rate, breathing rate, ensures that the cells in your body are being provided with the necessary nutrients. Low cardiorespiratory fitness levels are associated with higher mortality rates due to cardiovascular disease, cancer, and other causes of death. So regular exercise is important to decrease your risk of disease and to increase your quality of life. So endurance runners, like marathon runners, they have an exceptional level of cardiorespiratory fitness, but they do push their body to the limits when they do run marathons. All right, so we've looked at the main complications of the muscular system. How does the motor system support and interact with other body functions? So we'll look at that next, how the motor system interacts with the digestive, circulatory, respiratory, and excretory system. So we know that the muscular system is important for the functioning of almost every other body system involved in the digestive tract, in the pleural cavity of the respiratory system, the pumping of the heart in the circulatory system, the elimination of urine from the urinary system to bladder. So muscles play an important part in all aspects of life, and they have an important role in homeostasis. So in this flow chart, we're looking at the muscular system, and we're looking at how the muscular system works with other systems in the body and how the other systems support the muscular system. So the muscular system, it's comprised of the cardiac, smooth, and skeletal muscle tissue. We'll take a look at skeletal muscle tissue as well in the blue. So these muscle tissues, they contain myofibrils that contain actin and myosin myofilaments, and the action of those permits muscles to contract and also produce heat in the process as well. So let's start with the digestive system. So we have smooth muscle in the digestive system, and the contraction of that smooth muscle accounts for peristalsis. Skeletal muscle will also support and help protect the abdominal organs. The digestive tract, in turn, provides glucose for muscle activity. The liver metabolizes lactate following any anaerobic muscle activity. The circulatory system, muscle contraction keeps the blood moving in the heart, in the blood vessels, and in the lymphatic muscles, the lymphatic vessels. And these blood vessels, in turn, they deliver the nutrients, the oxygen that the muscles require. They also carry away the wastes. The immune system will protect against infection. Next, the respiratory system. The muscle contraction assists with the breathing. Physical exercise increases respiratory capacity, and in turn, the respiratory system, the lungs, provide the oxygen for the muscles as well as getting rid of the carbon dioxide from the working muscles. And then the excretory system, the smooth muscles, the contraction of the smooth muscles assist with voiding the urine. The skeletal muscles will also support and help protect the excretory organs. And in turn, the excretory system, the kidneys, they maintain the blood levels of sodium, potassium, and calcium, which are needed for muscle contraction, and then they also eliminate the wastes.